Hi, and welcome back to Algebra 1. Our goal for today is to continue working with our factoring polynomial expressions completely, including when we have a special case where we can't factor. And when we can't factor, we have what's called a prime polynomial. So can we mix these prime ones in and still be able to get to our factored completely version? So at this point, you should understand how to factor completely, which is I check for my GCF factor. Then I go to my chart method if my degree of my polynomial is 2 or higher and see what my final factored version is. So for today, we want to rule out we can't do GCF, we can't do chart. When we can't factor at all, it's a special polynomial that is considered prime. So we're going to look at 4 different scenarios today in your note packet. So scenario number 1 is I can factor. I have a degree of 2 or higher, so I should be looking for GCF and chart. Right? And in this case, I can only factor the GCF, which is not prime. As long as I can break it up into things that can be multiplied to get back to the original, I have done the process of factoring, so be careful. So in this case, we have a 3x squared plus 12x minus 30. So my first step is always checking for a GCF factor. So in this case, 3, 12, and negative 30 all have a common factor of 3. X squared, x to the first, no x, means they don't all share an x. So the GCF factor here is just simply a 3. All right, so we'll go through our leftover factor. We have a factor here now of x squared, a factor here of 4x, and a factor here of minus 10. Now, since inside our leftovers still has a degree of 2 or higher, we would go to our guess and check chart next to see if we could continue to factor further using our chart method. So we need factors here of negative 10 that add up to our linear middle term of 4. You need to go through all your guess and check here and see if we have a magic combination that says, although we've already factored, can we continue to factor further? So to get 10, 1 times 10, and then to be a negative, one has to be positive, one has to be negative. So negative 1 times 10 or a 1 times negative 10 would be a combo. So both of these would not give us a sum of 4. So we'd rule those out. Now the only other factors of 10 would be 2 and 5. But remember, a negative 2 times 5 or a 2 and negative 5. Again, both of those would not end up giving us a sum of 4. So in this case, we couldn't factor any further. However, it is not prime because we have 2 factors. We have a factor of 3, and then we have this leftover factor of x squared plus 4x minus 10. So scenario 1 is I can factor, but only by GCF. That is not considered prime. Scenario number 2. All right, scenario number 2, we have a quadratic trinomial here again. So that means I have to look for both GCF factors and my chart factors. This scenario is slightly different from scenario number 1 because x squared minus 7x and 6 don't have a GCF. So I'm going to go straight to seeing if I can factor with the chart. If I can, it's not prime. If I can't, then I'd be completely stuck. I wouldn't be able to do any factoring, and that's when we would call it prime. So we're going to go to our guess and check. We need factors of 6 that would end up giving us a negative 7. All right, so 1 times 6 seems like a good combo. However, 1 plus 6 would be 7, not negative 7. So remember, your other option here would be a negative 1 and a negative 6. All right, there's our magic combination. So for this one, we can factor further using our chart by breaking up this negative 7x into the terms of negative 1x and negative 6x. So we have an x squared minus x minus 6x plus 6. And since we were able to take that trinomial to a quadrinomial, we can now do our chart and get our additional factors. So we have x squared minus x or minus 1x and minus 6x and a 6. All right, row by row, column by column, pull out your GCFs to get your 2 factors. So x squared and negative x both share an x. Factor it out. Negative 6x and 6. Remember, this is a star block. It's negative. This automatically comes out, so this would be a negative 6. Be careful there. All right, x squared and negative 6x both share an x. And again, this is a star block. This automatically is going to come out. Negative x and 6. All they share then would be a negative 1. So our factors are going to be 2 linear binomials, an x minus 6 and an x minus 1. And since we were able to take the original polynomial and break it up into anything that could be multiplied to get back to the original, this one is not prime. All right, scenario number 3. I can factor by pulling out a GCF, and I can factor with my chart. Clearly, that's not going to give us prime, and in this case, we'll end up with 3 factors, our GCF factor and our 2 binomial factors we get from our chart method. So in this case, 2x squared, 10x, and 8 all have a common factor of 2. All right, so as soon as I pull that out and I have leftovers, prime's out. Right, that's not an option because I've now broken it apart. It's done a little bit of factoring already. All right, so we get an x squared plus 5x plus 4 left over here. And now we want to see, since inside our leftover still is a degree of 2 or higher, we have to check to see if we can factor further with our chart. So our chart method, we need factors of 4 that give us that middle term of 5. We're looking for things that multiply to give us 4, and when we put it together, we end up with a 5. All right, so 1 times 4 is our logical combo here that gets us there. So we're going to break up that 5x into 1x plus 4x. This middle term is breaking up. So we have 2 times x squared plus our 1x plus our 4x plus 4. All right, now that we have a quadrinomial, we can go to our chart, factor out our GCFs, and get our other 2 factors. X squared, x, 4x, and 4. Row by row, column by column, pull out your GCF. So x squared and x both share an x. Factor it out. 4x and 4 both share a 4. Factor it out. So we have a factor of 2. Right, bring it down. Don't forget that, guy. We have a second binomial factor of x plus 4. And then we're going to have a third factor for this one from our column. So x squared and 4x both share an x. X and 4 both share a 1. So we have an additional factor of x plus 1. So we could definitely factor this one, and more specifically, we ended up with 3 factors when we were done. A factor of 2, a factor of x plus 4, and a factor of x plus 1. Definitely not prime. We were able to take the original problem and break it apart. So scenario 4 is what happens when we actually have a polynomial that is prime, which means I can't break it up at all. I can't break it up by GCF, and I can't break it up by chart method. So this is what would happen when I go through all my work to check to see if something can be factored or if it's that special case called prime. So in this case, I would look first always for my GCF to see if there is one. So x squared, negative 2x, and 16, they don't have a common factor. There's nothing I can pull out. However, it still has a degree of 2 or higher, so I have to go to my guess and check to see if I can go to my chart method and factor it further. So in this case, we need factors of 16 that give us that middle term of negative 2. Do your guess and check. You have to eliminate every single possibility over there as a not correct option before you can say prime. Make sure you do the whole list because sometimes we just miss something and then we say something's prime when it's not actually. All right, so 1 times 16, negative 1 times negative 16, 2 times 8, negative 2 times negative 8, 4 times 4, and negative 4 times negative 4 would be our options here, right? Those would be all our things that would end up giving us a 16 if we were to multiply them. So I got to check them all. If any of them give us negative 2, we're not stuck. We keep going. If none of them give us a negative 2, then that's when we'd say we're stuck. We can't do any factoring. So this would be a 17, negative 17, 10, negative 10, 8, negative 8. And none of these add up to our magic combo number of negative 2. And so over here, I'd say this polynomial is a special case, which I have to describe as being prime. I can't break it apart into individual factors. All right, I hope that helps you attack your work for today. See you guys later.